Hi guys, so let's do a different take on regression in this video. If you look at the desktop, you should find the GRETL icon. Double click to fire GRETL up. GRETL opens up with a blank slate. To get some data in, let's go to File, Open Data, Sample Files. Click this and you have 3 very nice textbooks, and these are the data contained in these books. Let's use the Ramanathan textbook. Incidentally, Ramanathan is the person who invented GRETL or started the package many years back. We will use the data 7-9, which is first year's GPA of students. Double click and we have the data loaded. So here we have a number of variables. The variables of interest is going to be GPA at college and high school GPA. So let's do a model where high school GPA can be used to predict college GPA. First thing to do, of course, is look at the histogram. That's the histogram for college GPA. For high school GPA, same thing. Click on the variable, then right click and frequency distribution. Go OK. And there is the distribution for high school GPA. So high school and college looks pretty similar, with a mean around 2.6, 2.7 for college GPA. The mean for high school seems to be a little bit higher, at about 3.5, 3.6. What do you think the relationship between the two variables are? We can check that by selecting both variables and getting the correlation. So right click again, get the correlation matrix, and we find that it's about positive 0.4. Let's draw a scatter plot. Here is a scatter plot of the relationship of high school GPA and college GPA. As you see, we have individual observations, and it looks positive correlated as it shows with the correlation matrix. We can in fact draw a line. Let's try to do that. So select these again, the two variables of interest, right click and say XY scatter plot. And on the x-axis, the independent variable is high school GPA. Click OK, and there is the line. So it's positively sloped. And here is in fact the regression line. To see more information on the regression line, hit Model, OLS. The dependent variable is college GPA, set as the default. Independent variable is high school GPA, and go OK. There it is. So we have the regression right there. So the coefficient that we're interested in is this one. That's beta hat. So whenever you run a regression, you check 3 things: the sign, the significance, and the size. The sign is positive, which means higher high school GPA corresponds to higher college GPA. It is significant because the T ratio is bigger than 2 in absolute terms. You also see the stars here. And the size means 1 grade of high school GPA corresponds to 0.5 grade in college GPA. Let's do something a little bit more interesting. So if we go back to GRETL, let's add a few more variables. We have verbal SAT scores and math SAT scores. So let's see whether GPA at college is affected by verbal and math SAT scores. So we can go to Model, OLS. We're going to put our college GPA there as the default. Select the verbal SAT score and the math SAT score, and we get this model. Now, you'll see that the numbers are 0.00084 and 0.0. Now, this is not so nice to read. In this case, it'll be better to do what we call a log-log model. So using your control button, you can select the 3 variables of interest, and we can get logs of these variables. So right click and say add logs, or you can go to add and logs of selected variables. Either way, you'll get the logs down there. And let's try to do what we call a log-log model. Model OLS, one more time. Then we're going to, instead of college GPA, we're going to put the log of college GPA. There we go. And instead of just the verbal and math score, we'll put the log of the verbal and log of the maths SAT score. Hit OK and look at our results. Now we have something a little bit more easier to understand. A log-log model means that 1% increase in the verbal SAT score corresponds to 0.14% increase in college GPA, while 1% increase in maths SAT score corresponds to 0.35% increase in college GPA. So it's a percentage change in one of these variables affecting the percentage change in the college GPA. Looking at these coefficients, about 0.13% and 0.35%, we can conclude that maths SAT scores are more important in determining college GPA scores. GRETL can even do a 3-dimension graph. You can go to graph, fitted on actual, and you can see on both verbal and maths SAT scores. Wow, look at that. Doesn't that look nice? So you have log GPA here, verbal SAT, and log math SAT. So this time it does not draw you a line, but it draws you a plane. And we also see that the signs are positive. So both verbal SAT and math SAT scores are important. Both variables are significant. T ratios are bigger than 2, or you can see the stars here. And we see that in relative sizes, maths is almost double that of verbal SAT score in determining college GPAs. And I've touched just a little bit of what GRETL can do, but there are some limitations and you need to use some tricks sometimes. Let me show you a very useful one. Here we have dummy variables for those students that are science majors, students that those are social science majors, and those who are humanities. For example, if I select variable 1 to 5 and enter, if you look on this side, the first person, this is a 1, which means these are the scores for a student who went into sciences. These are zeros, which means student number 2 and 3 did not major in the sciences, but majored somewhere else. But let's say you would like to find what's the average college GPA for students that are majoring in the sciences. How can we do that? So the trick is to use interaction variables. So we can go like add, we can define a new variable. Let's call it science. So SC interaction, I can put a big X. I want to know the college GPA. So college GPA. And this is equal to, so I'll multiply the science dummy, DSCI, times the college GPA. When you enter, now you open this, you'll find that these are the GPA scores for those students that are in sciences. But you get a 0 here. But this is not really 0, it's just missing values. You can change zeros, you can set zeros as missing values, so don't get the average of this variable as it is. And to do that, you can go to data, set missing value code, so it's going to be 0, so zeros are going to be missing. If you hit OK, now double click this and you see that now we have gaps. So student 2, 3 are not science majors. And we can now get the mean by clicking right and say summary statistics, and that's the average college GPA for science students. We can do the same for those in social science, etc., and compare their records. Okay, that's it from me for now. See you in the next video.